chapter, or last set of notes yesterday, we finished them in class. We found derivatives, right? We found a bunch of derivatives, or to use to find the slope of the tangent line, right? Let's see. They look like this. We use this guy, right? We use this guy to find the derivative. That guy works every time, but it takes a little bit of time. Like the notes, the work you did that you're going to turn in or that you turned in, there's a lot of work to it, right? There's a lot of work to it. So there are other methods of finding the derivative. Okay. So here, let me see. I put it on the board too, but here. These are all the problems that we did in the notes last time. These are the original functions, f of x. And then when we found the derivative, these were these guys over here. So without looking at your notes, don't look at your notes, look up here. What is there a shortcut? Is there a shortcut besides having to do this guy? Right? I can do that guy, but it takes a little bit of time. So what I want you to do is think about it for a little bit. Oops, not that. Is there a shortcut? Is there a shortcut from going to the left side, from the left side to the right side? Because that's essentially what we're doing, right? Is there a shortcut I could use? Think about it. Think about that. Is there a shortcut I could use? The answer is yes, but can you find the shortcut? Yes, Rishi?
I don't know, I remember this doing like in math 3.
Uh-huh.
So we did like you take the power and then multiply it to the coefficient.
Okay. So you take the power. Let's see. Let's see if that works. So let's start with the first one. The power, right? Each power here. You move it to the where? So it's going to be in front, right?
Yeah.
Okay. And then what happens to the old power?
It's decreasing, so it becomes 1.
There you go. This is called the power rule. It's the first rule. It's the one you're going to use the most often. What you do is, if there is a power, you move it to the front. And then this power decreases by 1. So this 2 would move to the front. That's why the 2 is up here. And then I subtract 1 power. You always subtract 1. And it becomes that. Let's look at the second one. Does that work here? If I move the 2, what happens if I already have a coefficient there? What happens then? Multiply. Yeah, you're going to multiply. That's going to make -4. This becomes a 1, x to the first power. This one, the power is 1, right? So when it went over here, it multiplied here to make -7. And then what happened to the power? Yeah. Anything to the 0 power is 1. The power, it disappears, right? I don't need that anymore, right? The third guy, don't worry about. We'll get to the third guy. Third guy is kind of kind of crazy a little bit, because it's got a fraction to it. So let's look at the last one. The last one here. The 2 moves to the front. Subtract 1. What happens to the 4? Why did the 4 just plain go away over here? There's nothing. There's no remnants of the 4. Why did the 4 go away? Mm-hmm. There you go, right? There's always this, right? And when I multiply here, poof, goes away. Anything times 0 goes away. Yep. Okay. So from the left to the right, what's happening to the powers? What's happening to the powers as I go from f of x to f prime? What's happening to all of the powers? By 1 whole. Yeah, they're decreasing by 1 whole unit. So the third one, is that the same as the third one? The third one seems to be going up, right? It goes from x to x squared. Is that what's going on there?
Since the answer's on the bottom, you can't actually rewrite that as for the first one. That can be rewritten as x to the -1.
Yep. And then if I move that guy over here, that becomes negative, right? And then if I subtract 1 power, that becomes a. So this guy is actually negative. This guy is actually negative x to the -2 power. So it did go down in power. Even though it looks like it went up in power, it actually went down in power. That's the power rule. Okay, that's the rule you're going to use almost every time you find a derivative. Almost every time you find a derivative, it's right here. It's written in math lingo, but I wanted to talk about it. So if a x or any kind of variable has a power, right? That power is going to, when we find the derivative, that power is going to move to the front, multiply by whatever power was already there. And then you're going to subtract 1 from the power that was there to begin with, just like we did. Okay? So here we go. Let's try letter A. So I'm going to take the 5. The 5 is going to move to the front. There's nothing there. Or not, I shouldn't say nothing, because there is something there, but it's a 1. So the 5 moves to the front. And then I subtract 1 power from the power that was already there, and it makes 4. That took us about 30 seconds, if that. Probably more like 15 seconds, right? I went very slow on that one. How long would that have taken you yesterday if we did it like the way we've been doing it? Mm-hmm.
5 seconds, maybe more, depending on how good you are at it.
If we had to use this guy here, it would have taken a lot longer, right? Yeah, a lot longer. This is important because you will see it. But if we're trying to find derivatives quickly, this is the way we do it. We use the rules for differentiation. Okay, we use what's called the rules for differentiation. Okay, um, the rules, the first one is the power rule. So let's do 1b. 1b has a power. What is the power for 1b? Is it squared? Is it to the third? Is it neither? What is the power for 1b? What is this guy's power? 2/3, yeah. If we have the power goes on top, the root goes on the bottom. So it's actually 2/3. Okay. So now if we're going to find the derivative of it, 2/3 moves to the front. So I have 2/3 x. And then I got to subtract 1 whole. 1 whole. Well, if I subtract 1 whole from 2/3, what am I really subtracting? 3/3, right? It's probably a little easier. So that's negative 1/3 power. Okay. Let's clean that up so we don't have negative exponents. Okay. So what that means is we have 2 on top, 3 on bottom. Negative exponent means it's going to move down to the bottom. What does 1/3 power mean? What's another way of saying 1/3 power? Cube root. Yeah, cube root. The cube root of x. The biggest question I have is, Mr. Flores, what happened to the negative? There was a negative there. What happened to the negative, right? I had a negative 1/3, but my final answer doesn't have a negative. What happened to it?
With negative exponents, you have to turn around. So you have to put it into a fraction.
What does this negative mean? It doesn't mean a negative number. What does this mean? It means it moves to the bottom. Yeah, so that's why this whole guy moved down with the 3. Downstairs. If it was already downstairs, it would move upstairs. Okay. All right. Letter C. Letter C. Well, this one's kind of like the one we did. This is kind of like this guy here. All right. First thing you're going to do is get rid of the division. How do I get rid of the division? How can I write that without a division sign? There you go. Move it up. Move it upstairs. If you move it upstairs, we can't finish with a negative, but it's useful because we start with a negative. Or it's easy to use the power rule, you have to have a power. Okay? So f prime of x equals this power moves to the front, multiplies by what's already there. Well, a 1 was already there, so it's a -4. And then x, and then I got to subtract 1 whole power, means that's a -5. Okay? Now I can't finish with a negative. So now I have to clean it up. -4 doesn't have the negative exponent. It's x that has a negative exponent, so that one moves downstairs. Only the thing that has a negative exponent is the one that either moves upstairs or downstairs. Okay? All right. So that's the power rule. We're going to use that one a lot today. So we'll come back to it. We're going to use it a lot throughout the year. Power rule is probably the most commonly used derivative rule. Okay. The next one is a constant. If you have a constant, the derivative of a constant will always be 0. So 5 is a constant. So the derivative of 5 is 0. Any constant, any number without a variable, the derivative is always going to be 0, no matter what. Okay? If it has a number, if it was 5x, then we'd use the power rule. Okay? All right. The constant multiple. This one's kind of an offshoot of the power rule. If there's a number in front, what if there's a number in front? What do? Well, we said that earlier, right? We multiply it. You multiply 7 or the power times whatever's there. So f prime of x is 7 times 5, which is 35. Subtract the power. There's a derivative. Okay. Letter B. How can I rewrite letter B so that I can use the power rule? How can I rewrite letter B? Because the way it's written right now, I can't use the power rule. But how can I need a coefficient. So what would the coefficient be for this guy? 4/5. I like that. 4/5. And then times x. There you go. X will be to the -3 because x is on the bottom. So it's a -3 power. Now I can use the power rule because I have a coefficient and I have a power. So we take -3 and multiply it times what was already there. And then we got to subtract 1 whole. So 3/1 times 4/5 x to the -4. So that's, what is that, 12/5 x to the -4. Can't finish with a negative exponent, so now we move x back down. This guy, we move back downstairs where it was begin, and it'll be positive. So 12/5 to the 4th. The biggest part, the hardest part about this, or the most mistakes I see, isn't with the calculus. Students know, oh, I multiply this times this. Okay, so I got 3. Wait, I did something wrong. Yeah, it's negative. Thank you. Yeah. When I multiplied up here, I should have multiplied by a -3 because it was -3. So it should be -12. Things like that are the biggest mistake. The mistake I just made there, things like that. Has nothing to do with calculus. You know the rules. It's just you figure the multiplication, multiplying the fractions. This is a huge one. This is a huge one. Being able to see, okay, that's x to the -3. A lot of students can't see that. They can't see how it goes from x to the 3rd to x to the -3. right? And then they can't see how I put it back. So it becomes x to the fourth, right? Those are the biggest things. Exponent rules are the biggest ones. Okay? Okay, another offshoot of the power rule is called the sum and difference rule. The sum and difference rule, when we're adding things together. So it's using the power rule multiple times. Using the power rule multiple times. That's all it is. Okay? Using the power rule multiple times. That's all it is. 3 moves to the front. Subtract 1 power, I get squared. 2 moves to the front, multiplies times what was already there, that becomes 8. Subtract a power. 1 power was already there, moves it to the front, that becomes -2. If I subtract a power, power goes away. What's the derivative of the constant of 7? 0. There you go. That's the derivative. Move the power to the front, multiply, subtract 1 power. That's it. That's the power rule. Move the power to the front, multiply, subtract the power by 1. Okay. So this guy here, I need a coefficient for before I start using the power rule. I need a coefficient and I need a power. So let's look at the first part. Let me highlight this so I can. So we got 3 terms. We got that guy, we got that guy, and we got that guy. Those are the 3 terms, right? So the purple fuchsia color, what is my coefficient going to be? No. What do I have to do first here? It's all to the 4th power, right? So I have to 4th power everything. So what is -2 to the 4th power? 16, right? So this is actually this. What is the coefficient now? What is the coefficient for that guy? 3/16, right? So 3/16. What is the power? -4. Good. Now let's move to the yellow. What is the coefficient for the yellow? -1/2, 1/2. And then x will be to the 1st power because it's on top. So it's 1st power. 1/4 is just 1/4. But because it's a constant, it's not going to have a derivative. Okay. Power rule. Power rule. Move to the front. Multiply. Move to the front. Multiply. And then subtract 1 from the power. Okay. So I get -12/16 x to the -5. -1/2 with no x. Move it over here. -12/16 I can reduce. That reduces to -3/4. -5 power. It's got to move downstairs back because it's negative. So it's going to move this negative sign here You can move to the front, you can move on top, you can move to the bottom. It doesn't really matter where you move it, as long as you have it there. The negative sign in front of the 3/4, 3 over 4x to the fifth. Okay. Power rule. All you got to remember about the power rule, old power multiplies to the front. We take it, move it to the front, multiply it. Okay. New power subtracted, it gets and then it gets subtracted by 1. Okay. So this is the power rule right here. The hard part about that is sometimes the coefficient is not clear. Sometimes the power is not clear. Okay. So if we're going to find the derivative, we move the power to the front, and then we subtract 1 power up there. Okay. That's the power rule. That's how you figure out. It's the most widely used rule of differentiation. Okay. Example 4. Or no, my numbering's off, I think. Yeah, this should be 5. Okay. We've had this question before. If you look at your notes from the other day, we had a question that says find the equation of the tangent line to the function, whatever it was, right? We did it that way. We can do it that way, but I think the power rule's a little easier to use. So when you see equation of the tangent line, what should be going through every single one of your heads? Find the derivative. Yep. Find f prime. If we do not have it, find it. If we have it, we're good. Okay, find f prime. So that's the first step, f prime of x. Okay. So we move the 3 to the front, multiplies with the 4, becomes a 12. Subtract 1 power, it becomes squared. The negative 6x, move the power to the front, multiplies with the negative 6, becomes negative 6. No more x, it loses its power. And plus 5 is a constant, so that one goes away. That's the derivative. Done. The derivative is a tool. It's going to help us find the slope, right? So to find the slope, I have to plug in that guy. Okay, plug in 2. 2 squared is 4, times 12 is 48, minus 6 is 42. Okay, so the slope, that's the equation we got to use. The easiest one to use. We need a slope and we need a point. We've actually did this. So we actually did this. We did this. Let me show you right here. We did it for example number 3 yesterday. And then we did it. I think there was another one where we had to do it too. Number 4 yesterday. We've done this stuff already. We're just using the rule. We're using a different rule instead of the definition. Okay. So 42 is the slope. So 42 goes here. They gave me the x. So I can plug in 2. How do I find the y? Mm-hmm. Yep, f of 2. See, 4 times 8 minus 12 plus 5. What do we get? 32 minus 12 plus 5. 25. So the point is at 2 comma 25. You're done. Same steps we did yesterday. The ones you did on your delta math assignment, same steps. The only difference is when we find the derivative, we use the power rule instead of the definition. It's quicker, it's faster, it goes by faster. That problem yesterday would have taken us double, triple the time. Whereas today, it doesn't because we have the power rule. Okay. All right, let's see. Okay. Now let's look at number 6. Okay, number 6. Number 6 is a multiplication problem, right? It's a binomial times a binomial. Binomial times binomial. My question is, how do I use the power rule? Power rule is pretty simple, pretty basic. How do I use that? I've only learned the power rule. So how do I use the power rule here? Hmm? That's what we're going to have to do. Yeah, that's what we're going to have to do. We're going to have to multiply it out and then use the power rule. A lot of people will say this. That's good because a lot of people, I get this, will say, oh, just find the derivative of this guy and then find the derivative of this guy. So this guy would be 8x here, and then the derivative here would be 2, right? And then multiply them together and you get your answer. I'm like, that's not what the power rule says. Power rule doesn't say. Power rule just says move. It didn't say anything about multiplying the answers together, right? So what we have to do is multiply them out. Multiplication box, FOIL, whatever method you're used to, multiply them out. First, let's see, h of x. So 8x to the third, outer, minus 20x squared, inner, plus 2x, last, minus 5. No like terms to combine. Use the power rule. See what you get. Do it right now. See what you get. So the derivative is always prime. So the original was h, so this one's going to be h prime. So we get 24x squared minus 40x plus 2. The negative 5 we don't worry about because that's a constant. Done. Okay. All right. All right, let's take a look at, okay, so now I'm going to give you another rule. This one is called the product rule, the product rule. So now we're going to get into multiplying things. When I have two functions being multiplied together, I can use what's called the product rule, right? One function is called u, one function is called v. So here is the setup. If I have two functions or two separate things being multiplied together, how do I find the derivative? Well, the first thing you do is rewrite u. Whatever u is, rewrite it. And then you're going to multiply that times the derivative of v. And then you're going to add, so you're going to add this guy with this guy. You're going to rewrite v, find the derivative of u, and you're done. Okay? So it's the first times the derivative of the second plus the second times the derivative of the first. That's the product rule. Okay? So we have a problem kind of like we just had last one, right? We could have used the product rule on number 6, but we didn't know about it until now. So number 7. Okay. Before I use the product rule, though, I have to make sure everything's got a power. Okay? So the product rule says, let's see, let me write it a little differently. Okay. So we take the first times the derivative of the second, and then add that with the second times the derivative of the first. That's the rule. Okay, so the first guy I'm going to call g of x. I'm going to call this guy right here g of x, or f of x, sorry, f of x. And then I'm going to call this guy g of x. I'm multiplying them together. F of x, 3 is a constant, right? Okay. What's the power for x with 2? 2, it's right now it's 2 times the square root of x, but I need a power there. So what power will it have? 1/2. Okay. So let me rewrite this. So it's y equals 3 plus 2x to the 1/2. G of x looks good. We got a power and a constant. Okay. That does look good. All right. So let's use the power rule. Or the product rule. Okay. So the first thing says the derivative. So we have yellow is f, purple, pink is g. So we have to, so the first thing we're going to do is rewrite the first one. Rewrite the first one. Okay. So rewrite the yellow. And then I'm going to multiply that times the derivative of g. The derivative of g. The derivative of g is just going to be 15x squared. Plus. Okay. Now the opposite, the second one, g of x times the derivative of the first one, the original, the yellow one. Okay, well, 3, the derivative of 3 is just 0. The derivative of 2x to the 1/2, I move 1/2 to the front. So when I move 1/2 to the front and multiply it with 2, what do I get? 1. So it's going to be x, 1x. And then what's the new power going to be? If I subtract 1 whole, what's the new power going to be? Negative 1/2. Good. Negative 1/2. Okay. That's the product rule. Here's the thing. Here's the thing with the product rule. If this is a free response question, you're done, move on to the next one. But more than likely, this problem you will see on a multiple choice test, A, B, C, D, E, and they will never finish there. They will always keep going. Okay. So students say, am I done? Yeah, you are done. We don't have to use the product rule anymore. You're done. Product rule's been done. But if this is a multiple choice question, this won't be one of the answers. It won't be, I'm telling you right now, it will not be one of the answers. So do you have to keep going? Well, if it's a multiple choice test, you do. If it's a free response, you can stop and say you're done. But you won't, I'm telling you right now, you won't see this question on a free response. So I'm going to keep going. I'm going to keep going. How do I keep going? Distributive property. Okay. So I have 45x squared plus 30x. If I'm multiplying, what do I do with the powers? Add them. Yeah, you don't multiply them, you add them. So 2 plus 1/2 is 2 1/2, or 5/2. And then the other guy, 5x, if I were to add 3 plus 1/2, I get 2 1/2, which is again 5/2, minus 7x to the negative 1/2 when I do distributive property. Combine like terms. (45x squared) plus 35x to the 5/2. And then this guy over here, I can't combine it, but I have to change it so it doesn't have a negative exponent. So it's going to be 7 over square root of x, because 7x to the 1/2. That part right here, this part right here, this part right here is where students will make a mistake. That has nothing to do with calculus. That's just algebra, right? Distributive property, combining like terms, moving this guy to the bottom. That's where most of the mistakes will be made. Product rule, you guys are pretty good at. Like, we'll do product rule enough where you'll be like, oh, I know what to do. It's everything after that. So just be careful when you're doing these, because that's where the mistakes are made. Okay, that's where the mistakes are made. Not necessarily with the calculus part, it's with everything after that. Okay. All right. Let's try this one. I want you guys to try B on your own. Try B on your own, and then we'll go over it in about 2 or 3 minutes. Okay, so when you use the product rule, you rewrite f times the derivative of g, and then you rewrite g times the derivative of f. Again, that's it. Product rule is done. There's no more calculus to be done. But on a multiple choice test, that answer will not be there. I'm telling you right now, it will not be there, because you have to finish it out. So that guy I have to multiply. So I get 15x minus 10x squared. This guy I'm going to have to use FOIL. First, 12, outer, negative 16x, inner, positive 15x, last, negative 20x squared. Combine like terms. Let's see, x squareds. I have that x squared, that x squared. So what do I get? Negative 30x squared. Then I have 15x, negative 16x, positive 15x, negative 1 plus positive 14. And then plus 12. Okay. We're going to stop there, because the next one we're going to go over tomorrow is called the quotient rule. That's the last rule that we're going to go over. And then the last thing is higher order derivatives, which is just finding derivative after derivative. It's not as hard as it looks. Okay. Okay. So we'll stop right there, and tomorrow we'll start with quotient rule. Okay. All right. So save this for tomorrow.